Hi, I'm Joe Germino. I'm a third year biomedical sciences student at UCSF, and my research interests are primarily in the fields of immunology and computational biology, which I became interested in while studying as an undergraduate at Washington University in St. Louis, but ultimately decided to continue throughout my PhD. So my research interests primarily focus on immune regulation, especially in the context of health and disease. So this is very important because at homeostasis, you have to have an equal balance of immune repression and immune stimulation. Whereas if you develop too much immune stimulation, you can develop an autoimmune disease versus having too much immune repression can lead to cancer. So one of the populations of cells that have to be regulated are T cells, which are one of the effector cell populations of the immune system. And these cells are unique in their ability to recognize pathogenic peptides on the surfaces of cells and induce pathogenic cell death through the secretion of inflammatory cytokines like granzymes, interferon gamma, and TNF alpha. However, during their development, T cells have to be tolerized or educated about self antigens to ensure that they only recognize pathogenic peptides. So this process is mediated in the thymus by an epithelial cell population called MTECs, which are uniquely able to produce self-antigen peptides under the control of very special transcription factors called AIR and FESF2. And this production of self-antigen peptides allows for the negative selection through the deletion or inactivation of any self-reactive T cells that maintains immune self-tolerance by ensuring that only T cells that recognize pathogenic antigens are able to escape into the periphery where they can mediate an inflammatory response. So in particular, I'm interested in studying other transcription factors that influence MTEC development, especially factors that can contribute to the multipotent stem-like character of these air-expressing MTECs. In addition, there's been recent descriptions of post-air states in the thymus, and understanding the functional importance of these post-air populations to immune self-tolerance is one interesting area of future research. And finally, I'd like to understand the transcriptomic and functional overlap between thymic air-expressing cells and a recently described population of extrathymic air-expressing cells that may have unique functions in terms of regulating immune self-tolerance. And finally, I'd like to conclude by thanking ARCS for their support, and I'm excited to see where this project goes with their generous support.